What is Terraform? Terraform is an open source infrastructure as a code tool developed by HashiCorp. It allows you to define and manage your cloud resources and infrastructure using declarative configuration files. With Terraform, you can describe the desired state of your infrastructure in code, specifying the resources, their properties, and their relationships. By declarative, it means that you don't have to define every step of how this automation management is done. You just declare what you want, the final result or end result, and Terraform will figure out how to execute it, versus imperative style, where you specify how to execute each step. When you use Terraform, you write configuration files in a human-readable language called HashiCorp Configuration Language or JSON. These configuration files define the infrastructure components you want to create, such as virtual machines, networks, databases, and more, along with their attributes and interconnections. Terraform then interprets these configuration files and interacts with the respective cloud service providers, APIs, such as AWS, Azure, and Google Cloud, to create, modify, or delete the actual resources to match the defined configuration. Now, to have some idea of how Terraform configuration looks like, this is an example where you can see Google provider configured, and through the provider, you now have two Google Cloud resources like Google Cloud Storage Bucket. You can create that with some attributes. Another example where you see AWS provider configured with AWS resource like VPC, that you can also create this with some attributes. Now let's have a look at the Terraform core workflow. When you are ready to work with Terraform, you initialize the environment using the Terraform init command. This tab downloads the necessary provider plugins, sets up the backend for state storage, and prepares your project for further actions. After initializing, you create an execution plan using the Terraform plan command. The Terraform compares the current state of your infrastructure, if any, to the desired state defined in your configuration. It then generates a plan detailing the changes that will be made to reach the desired state. Once you have reviewed and are satisfied with the plan, you apply the changes using the Terraform apply command. Terraform interacts with the cloud providers' APIs to create, modify, or delete resources as needed, ensuring that the infrastructure matches your configuration. If and when resources are no longer required, you can use the Terraform destroy command to deprovision them. Terraform will identify the resources based on your configuration and remove them from your cloud environment. Now let's have a look at some of the benefits of using Terraform. First and foremost is multi-cloud provisioning. One of the Terraform's standout features is its ability to manage infrastructure across the different cloud providers, such as AWS, Azure, and Google Cloud. This means you can use the same Terraform configuration to provision resources in various cloud environments, avoiding vendor lock-in and giving you flexibility to choose the best services from different providers. Next is consistency. Terraform promotes consistency by providing a unified workflow for infrastructure provisioning and management. Whether you are working on development, testing, or production environments, you can maintain a single set of configuration files and apply them consistently across a diverse environments. This reduces the risk of configuration drift and ensures that your infrastructure is reproducible and reliable. Next is collaboration. With Terraform, infrastructure is defined as a code. This means that your infrastructure setup is documented, versioned, and shareable just like software code. Teams can collaborate more effectively by using version control systems such as Git to manage changes to infrastructure configurations. This enhances communication, review processes, and teamwork among the development and operation teams. Lastly, automation. Terraform enables end-to-end automation of your infrastructure's lifecycle. From provisioning and scaling to updates and deprovisioning, you can automate the entire process using the Terraform's workflows. This automation eliminates the manual intervention and reduces human error, resulting in more efficient operations, faster deployments, and improved overall reliability. Now let's talk about some of the use cases of Terraform. Terraform has a wide range of use cases, including scaling applications. Terraform allows you to easily scale resources up or down based on demand, ensuring your applications can handle varying workloads. Next, infrastructure orchestration. You can define complex infrastructure sets up using code, making it easier to manage and reproduce intricate configurations. Next is a disaster recovery. Terraform enables you to quickly recreate your infrastructure from code, aiding in disaster recovery scenarios. Lastly, DevOps practices. Terraform seamlessly integrates into CI/CD pipelines, automating the provisioning and management of infrastructure for efficient development and deployment workflows.